Okay, test. Okay, I think everybody can hear me. Good evening to everybody that is here for class today. Thanks for being on time. So before I think we start with the lab, uh, of course, we may need to wait for some people lah. So maybe I'll just show a simple YouTube video as a refresher, uh, of engrams because for lack of better way of explaining it, the engrams today is going to build on, and then it's going to be sort of the most basic form of the chatbot. Okay, wait. Let me share. Let me look for sound. Share sound. Optimize for video.
Yash and
Okay. So we'll start in the lab after the video plays finish, but let's just have a refresher lah, of engrams, large engrams, and how engrams can be used for modeling lah. Okay, so because last week we talked about engrams.
we'll be talking about this n-gram language modeling. It's a very interesting topic and sort of in the direction of AI and NLP, but it's not so advanced. The n-gram language models are not so advanced, but it's a very simple way and still gives good results and outputs. So let's
Yeah, so I think one keyword that he's saying is that we're not jumping straight away into large language models, lah, right? So we are not doing large language models instantly, but engrams, as he said, is still the fundamentals of number one, natural language processing, the term that they didn't really talk about, but the fundamental definition of all these chatbot models, all these generative AI chat models have to understand for lack of better way, English or natural language, and as well as other languages lah. So the base we'll do is Ngram, then we'll progressively do a more recent concept lah, meaning that a uh, research more research applicable content. Ngrams is still used, but not as much as the other techniques that you learn every new seminar. Okay, so I'll just play this video for those that are here just because I'm waiting for people to come in. So I just have a short refresher of what the Ngram is for today.
see. And by the end of this video, I mean, you'll be able to build your own language model. So that is very interesting. Okay. So what exactly is language modeling? Now, it's just trying to build a model which knows language. That's the simplest way to put it. Okay. So let's say, for example, you are given this sentence and this becomes your input. This incomplete sentence becomes your input to the model, and your model gives the output as this next word. Okay, sort of like what it suggests, basically. So this is the intuition behind language modeling. It knows the language and it can sort of fill the missing piece after the sentence. And it's not very random. It knows like which word it can pick. It may not be the most accurate word, but it will not be wrong, is what I want to say. It knows the structure of the language. That is the essence of language modeling. So similarly, you can take this and again give this input by taking in this next prediction as well, and again it keeps producing these words. So you can just go on and produce your own text, write your own books using this language modeling, maybe create a library and whatnot. So the possibilities are endless with language modeling. It basically just knows what to print as the next word. That is the main motive of language modeling. So one of the big use cases of language modeling that we see is in these mobile phone keyboards. When you start typing a message, these three suggestion words come up. So if you have ever wondered how these words come up, they in the back end is basically a language model that is running, and it takes in this input and it sort of suggests you the words that you can sort of fill in next. So there are many ways in which you can build this language model, but we are going to talk about this n-gram language modeling. And
Okay, just pause a while. Is that of course I think then since we all lived before the age of GPT models, right? ChatGPT, OpenAI GPT models, right? Then you also notice that basic autocorrect is doing that prediction of what is the next word lah. And then engrams is one way to do that, which you explain.
You can build this language model, but we are going to talk about this n-gram language modeling and how it's done. It's based on probability theory, and yeah, let's go on to some theory now. So what exactly is n-gram? N-gram is
Okay, pause a bit. So I think this week one of my diploma students asked me, so what is the skill set that is needed to become AI engineer lah, or or more advanced analytics lah. So traditionally, for AI, one of the mathematical skill sets that is needed is probability lah. Okay, so what is probability? Is the chance of something happening. A good example would be if you flip a coin, that it has heads and tails. Usually we would say when we flip the coin, there's a chance of it being hit, and then there's a chance of it being tails, and it can be like a 50% chance of it being heads and then 50% chance of being tails lah. Similarly, a dice has six sides, one, two, three, four, five to six. You throw it, we would say that there is a probability of 1/6 of getting any number. So 1/6, the chance of getting the number one, 1/6, the chance of getting number two, so on and so forth. But if you know advanced statistics, then what I'm saying is a simplification lah. But just to let you know, the core skill set in AI is still probability. And you will notice that today's Ngram quote unquote model is highly based just on probability on its own.
a sequence of n words. So n in n-gram stands for number of words. So for example, I am the king. This is like a normal sequence of words, let's say. So 1 gram is like you chunk single word from this. So this I becomes a particular unigram, am becomes a unigram, the king, like that. So similarly, for 2 grams, you chunk it in a way like this. So considering this as a sentence.
Okay, so maybe a brief explanation. I think I talked about it last week as well. Ngram, N stands for a number that can be replaced by one, two, three, or four. That's why the example in the video is 1 gram, which is unigram, which is a single word as if you already know what I'm saying, as a feature. And then 2 gram is or sometimes called bigram, which you'll see the word bigram a lot later. So just not to confuse you in the lab, what bigram is bigram mean that in a given sentence you will you take patterns of two words lah. So in this case, I am the king lah, and then he'll show you a trigram as well.
Sentence, you can get bigrams as this is one of the bigrams, comes another bigram. Similar for I. Similarly, for trigrams, we have I am the and am the king. So these are the these are the two trigrams that we get from this small sentence. So these are all about n-grams. Now let's actually see the maths behind building a language model using these n-grams. Well, first, to calculate a unigram probability, that is, what is the probability of a word? Unigram is basically just a single word. So what is the probability of a word coming from the entire corpus? So n represents number of words in your entire corpus, and w can be any word. So what is the probability of that word coming? That is basically unigram. Now when we go higher, bigrams and trigrams, you will need this Bayes rule. I hope you remember the Bayes rule from the probability.
Okay, so the probability of the unigram is the probability of the word. The probability of the word equals to the count of the word divided by all the words in the set lah. So the probability, for example, if the word food exists out of 100 exists in 100 times out of 1000 times, meaning a paragraph, sorry. A paragraph has 1000 words. 100 words inside that 1000 word paragraph is food. So the probability will be 100 divided by the total number of words lah. And then that would be the guess, right? Because every time you see this word come out, you see the word food come out a lot, then you intuitively have a guess that uh, uh, there's a chance that if you say food, the chance of you getting correct is quite high lah. Yeah.
Theory. So what Bayes states is you want to find the probability of this event A when B is already given or B has already happened and you want to predict and you want to get the probability of A happening. So this is how it's calculated. So B has already occurred. So you will keep B in the denominator, and given that B has already occurred, right? So we need the probability of A and B happening together. So this is what comes in numerator. So A and B happening together upon only the probability of B happening, that's where you get this probability of A happening given that B has already happened. I'll show you how this is used to calculate higher order n-gram probabilities. So to calculate bigram probabilities, what the intuition is, you want to calculate probability of a word given the last word. So you want to calculate probability of ith word given that you know what is I minus one word. So you know the previous word and you want to calculate the probability of next word. So what you will do in that case is you get the count of these two words together, but your order also matters. So I minus one should be last and then I. So this comes in sequence divided by the count of I minus one happening in the entire corpus. So you see how many times this I minus one word occurs in your corpus, and divided by the number of times these two words occur consecutively in your entire corpus, and the sequence should be same. It should not be wi and then wi minus 1. It should first be wi minus 1 then I. And in the similar way you can calculate the probability of trigrams. So here you want to calculate.
Okay, so I think I won't let him continue, but just to say earlier is that later at the end of the class I'll put in the announcements this notebook lah. So this is a Jupyter notebook. I'll explain how to use Kaggle after this. Then I'll just send this with all the links so you can access it in your own time lah. So the lab notebook you can access in Canva, can access in Canva, and you can see the toy corpus text. But I just put everything here so it's easy to navigate through now. Okay, so later I'll send you. Don't need to. Uh, if you want to watch the video, you can watch it again at your own time. So hopefully you have understood what is being said here, lah, which is the bigram means that, uh, for example, if the sentence say I like food, three words, I like food. So a bigram probability will be I like, and then what is the probability of the word like happening given the word I came before that, lah. So then what it means is that what is the probability of the count of I minus one and wi divided by the count of wi minus one lah. Okay, then trigram you can see that it's what's the probability of I like food, right? So what's the probability of for example, if I say I like, the chance of the probability of the word food coming next is food will be the wi, the wi minus two will be I, the wi minus one will be like, and then you have to do a base you have to do the summation of the counts of the different probabilities of the word happening before that, and then divided by the counts of the summation of the probability of these two words happening lah. Okay, so as I said prior last week is that the consensus, or generally once you pick up a bit of machine learning, you will start to feel like, hey, how come machine learning AI is just all about math? And then you have the intuition that most of your mathematics is actually applied in machine learning and artificial intelligence lah. So in this case, n-grams is a very good way to explain that lah. Since most of you may not have taken machine learning, so it just goes to show that you have to build this intuition of probability lah in this case lah. Okay. So besides that, this video will be available to you, and then you can access it anytime you want after probably tomorrow or next week. I will share this notebook with you as well, lah. Okay. But besides that, since I said that, then maybe I put this in the chat first, lah, in case you urgently need it. Okay, so the first two things I need you to do is that I'll go through Kaggle, which is this platform. If you're not familiar with it, I will run through it first. I use Google Colab a bit more because that was the main tool that I used for showcasing Python code and using GPUs previously lah. Okay, or I mean my day to day lah. I use that normally. Okay, so the links that I send you, when you click on the lab notebook, it will download for you. You'll see a download on the Ngram. So you download and just open that first. And then at the same time, also click on the toycorpus.txt. You click on it, it will also download for you toy corpus txt lah. Okay, actually, I also need to yeah, I also need to download it, I think. Yeah, move this away. How do I move this away? Okay. Move this away first. Okay. So yeah, can download these two documents. If you don't have it, it exists in your files and your modules as well inside Canva lah. Okay. So how to access Kaggle? First of all, just type Kaggle on Google lah. Kaggle. So if you type Kaggle like this, you search on Google, you should be able to reach kaggle.com lah. Okay. So I click on Kaggle, and then maybe I'll copy the link for you, put on the chat. So kaggle.com is where you can run your code lah. Okay, so you log in. As you can see lah, I don't really use Kaggle lah. So I use other platforms lah. So inside, that's why I have a few notebooks only. So Kaggle is the website for a lot of data sets lah, if you don't know already. So if you haven't created a notebook, what you should do is that I'll give you some time to log in first. So let me wait for a bit. So you just log in first, and then you do some authentication, I guess, and then click on notebook here lah. So I'll wait for a while if you want to follow me. If you don't want to follow me, then just be patient and pause first. Yeah, but this is how you set up Kaggle lah. So I let you try to log in for the next uh few minutes first. And if you need any help, just either you can unmute yourself or you can type in the chat that I can help you lah. Okay, so log into Kaggle first, and you can play around with it first lah. But if you are fast, then try to create the notebook yourself and see if you can import the toy corpus text lah. So for example here, okay, sorry, let me go back. Go back. Okay, so for example here, I think if you click here, you for you is that if after you have downloaded the lab notebook in your that I put on the chat, if not in your Canva, right? You import the notebook and then you drag and drop the file here lah. So you drag and drop and then call it whatever you want first, okay? So I will give you all a bit of time first. So import notebook and then uh import notebook and then use the lab notebook and import it inside. Okay. Okay. So, if you still have issues to log in, yeah, you need clarification, you can let me know. If not, I will proceed lah. So, I will try not to upload the same notebook all the time, but then simply put it for yourself. It should be quite intuitive lah. Click the plus, import notebook, and then drag the lab one notebook, and then upload it lah. Then it will take some time. It will load, and then when it loads finish, you should be greeted with zoom in a bit. Okay, you should be greeted with something like a notebook lah. Okay, so what you will see, you won't see what I see, so you won't see all these details, and you also won't see some of the notes that I made below. But just to remind you is that of course I will send you I'll send you this notebook in the announcement so that unable to open the lab on Google Drive. Uh, you unable to open the lab. So Harjit says unable to open the lab on no lab notebook on Google Drive. You can. You want to open on Google Drive, is it? If you want to open on Google Drive, then you have to use Google Colab lah. Uh, but but strictly speaking, we are using we're using Kaggle for this module lah. Okay, so but let me show you give me a moment lah. Show you. Give me a moment. Okay, so for example, if I'm using if I want to open a Jupyter notebook in Google Colab, which I'm not here to explain you how to do it, but I will do it. Which is you need to install the app first lah. So I have Google Collaboratory here already lah, but then you need to press Connect More Apps, and then in the Connect More Apps you need to look for an installation here lah. Okay, but for this, as I said lah, for this module we are focusing more on. Oh, it's a bit laggy. Uh, Okay, so bear with me lah. If you haven't done this before, you want to try it, then to install it yourself here, Google Collaboratory, then you can run it there as well lah. Okay, yeah. So if you've never run it before, then you have to run it. If not, just try on Kaggle lah. Okay. So besides that, let's just if Harjit need more help, you can just type on the chat. If not, I'll walk through the code for today lah. Okay. So okay, that's it doesn't matter if you can open or not. Okay, I'm pretty sure some of you can open by either Visual Studio Code lah, Jupyter Notebook locally lah, or whatsoever lah. But okay, just follow along the code. There will be one or two activities for today only. Usually I will add activities to think, but I think because there is a lot of things to cover, I can't do that. Because today we also I'll try to walk through Python a bit slower in case you need a refresher lah. Okay, so this is a notebook and this is where the code will run. Okay, so for me, right, I can see the data sets on the right that says toy corpus because I have already uploaded it lah. Okay, so what that means is that this notebook it runs on Kaggle, and then when it's running on Kaggle, right, you are able to access the access Kaggle and this Jupyter notebook from anywhere lah. Okay, and then but at the same time, Kaggle lets you upload data sets lah. So the problem is that if you upload once, they won't let you upload the same file again unless you change the name now. Okay, so in the case, remember you downloaded the toy corpus txt. Toy corpus txt. What the toy corpus txt looks like is when you open it, the words are like this lah. So you'll see all these words here lah. But so how do you open it in Kaggle, right? Kaggle, you click on upload, you click on new data set, you drag and drop, and then you give it a name. Okay, maybe I give a demonstration. So when I click on browse files, I think you can't see it now, but I open the toy corpus txt, and then like you see the toy corpus txt is here. You type a name and then you press create. Okay. So you drag the toy corpus txt to just now the upload. So I don't want to continue, change it to continue. Continue. You press upload, new data set, drag and drop the file here. So in this my case, our case is toy corpus txt, and then you type a name for the data set called toy corpus whatsoever, and then press create. Okay. So that is it lah. Then after you wait for a while, after it upload, it will show up. There will be a data set here. However, whatever you named it, the data set will be here lah. Okay. So then this toy corpus txt you can access from your Jupyter notebook lah. So how you access it is you should be roughly familiar with path pathing, or if not, how to use paths within your computer lah. So how you get the path, you find this copy file path here, you find this copy file path here, and then you like when you Control V, right, you press paste, right, you will see here. You press paste, and then you see here lah. So I already pasted it lah. Okay, so I wait a while. And then because the screen is limited real estate, I will close it. So later then you can see all these things now. But I just repeat again. After you click upload, you click new data set, you drag and drop and you upload your file. And then it uploads, takes some time to load. You see that your file is here, you copy file path and then use this file path for your lab. So for your lab, you will then, so for example, my file path lah. So my file path is this slash kaggle slash input toy corpus dash toy corpus or txt lah. This is my file path. And coincidentally, what you see then is that the file path is here as well lah. Okay, the file path is here as well. Okay, so that is just some administrative aspect lah. So you will see, you just need to change this path to your own code lah. Okay, so the first code, let's see, can I make it smaller? Let me zoom out a bit. Okay, hopefully you can see. I don't know if there's a way to, yeah, make it look better. Okay, cannot. Okay, just the website, not easy to see. Hopefully you can see. So for Kaggle, right? Your notebook is something like this, right? But I will break down individual lines to explain it during the lab. So the expectation for the lab is that I'll try to explain the logic and each line of code if possible lah. Okay, each line of code is possible. Okay, so after you are able to put the correct path, right? Then you copy and paste, and then you run the code, right? Let me try to run it. I run it, right? I run the code. Yeah. Oh, it's still connecting. Sorry. Let it connect sometimes. While it's connecting, basically, I think if you're a new user, right, you cannot access the GPU straight away. So you'll need to use because I'll show you another time, which is the accelerator is here. You can use the GPUs here, but I think you need to connect to your phone number first lah, then it can work lah. So these GPUs are for you to run AI models lah, and it helps you run AI models faster lah. So that's why we're using Kaggle. Sorry, I forgot to mention that is the main reason why we're using Kaggle lah. That's because the GPUs here are free lah. I mean free up to a certain amount of time lah. Okay, wait my notebook is not loading. Give it a while so. Mm. Yeah, let me refresh it. I also don't know why everything is lagging. Here we are. Yeah, so I'll close it, I'll minimize it so you can see everything. Uh, let me run, session is starting. Okay, waiting for Jupyter. So you can see like it's loading on the top here. It says draft session, loading and waiting. Yeah, not sure why it's taking so long. Normally it's quite fast. Okay, still starting up. Okay, so I ran it already. Draft session running, it's running. Not sure what was the issue. So you can see, you should be able to run it already. And when you're running it, what you will see is this output. Okay, so I forgot to mention, of course, we will try to do the 45 minutes of class and then break for the remaining of the hour lah. But if no time, then we will just continue lah. Okay, but just that you know this part. Okay, so I will break down the code later at the bottom, but I'll just go through the high level overview of what this code means, which you have as well lah. Okay, so if you're able to make an intuitive guess, right, what you see here is that these are words that are being stored in a Python array and they're stored in tuples of two different elements each lah. So you can see R, comma 3, of, comma 2, and will, comma 2 lah. So what do you think is the definition of this above lah? So one way to read it is to read it as so you see R, comma 3, it means that the word R inside the data set, the toy corpus occurs three times. And then the off occur two times, the diet occurs two times, the electric appeared once. Lah. So that's just this whole data set is so small, so little words, and they almost of the words only appear once. Lah. Okay. So simply put it, I'll just go through the high level first of this block and this block line of code, then I'll go through in detail. Lah. Okay. So this is gonna be fast because this is just high level. Then I'll go through individual points later. Okay, so high level is that when you want to open this data set, you want to save it as a f variable. You can type any variable you want as f, and then this variable you define corpus. Corpus is the your Python variable that you define it. F dot read lines. You want to read all the words inside this text file into the variable corpus lah. So in the variable corpus, what you want to do is that you're doing this list comprehension. Later I will explain this comprehension again. You'll do a list comprehension. So list comprehension is a for loop, but then it stores straight away in the array. So what happens is that for sentence in corpus, for sentence in corpus, meaning each line of the corpus, which I'll explain later, you will split you will split it. So you'll split each line of the corpus. And then you will sort of use this other library called collections, and you import this thing called counter. And the long story short is that with another form of comprehension method, you will actually use a counter, and then from all the words that are being broken down, you will count, and then it will summarize as here. Lah. So what is this? This is actually the unigram, and this is the 1 gram. Lah. So your n-gram, this is your 1 gram slash unigram. Okay, so we'll go on. Uh, okay, yeah. So let me explain to you step by step what is happening. Lah. Okay. So if I run this line of code, so sorry, if you don't know how to run this, you just click the run cell. You can run all also. And then there's this other thing called markdown. I think you should be quite familiar with markdown. So same, you can add the markdown here, delete, can add the code here, can delete. Okay. So today the experience is going to be a bit of Python syntax. I'm going to explain a bit of Python syntax slowly as well. Okay. So there's no way to there's no need to purely understand the syntax of how to open the file, except just memorize it. Okay, but there are actually various ways to open files lah. You can use if you have knowledge in pandas, which you all have, is that you just do the read excerpt, or you do just a read file or read txt. Okay, so I think I don't need to explain lah. So this is just how you open. You save it as a file. You save it as my file. In this case, I use my file. Save it as my file, and then you define a variable corpus my file, and then you read the lines inside lah. There's no other way than just to memorize the syntax for this lah. Okay, so I will labor a bit to explain mini syntax points slowly, but then I will speed up as we get closer to the end. Okay, so if you open up the txt file, right, this is actually what's inside the txt file. So my corpus is electric cars, etc., the things that we talked about last week. So this is the text that's inside the corpus. So if the data set is small, what you can do is that you can open your toy corpus. Sorry, I forgot the file name. Toy corpus.txt, and then you copy and paste here. But the reason why I paste it is it's easier for you to see and easier to demonstrate. Okay, so for example, my corpus I call it my new variable, and I define it with the 3 quotes. So in Python, 3 quotes is just for multi-line strings, or for multi-line strings lah. So if you put single quote, I think traditional Python syntax doesn't work lah. But Python always updates itself, so I will lose track of what is the syntax lah. So these three quotes and these 3 quotes give you a multi-line string lah. So my corpus lines equals to my corpus dot split based on the new line. Okay, so let me run this. Okay, so you can see if I do if I didn't write it if I didn't write it like the one that is given, I didn't use the list comprehension, which you are familiar with, you should be roughly familiar with. I would write it like this lah. So I'll write this as my corpus dot split. Okay, so maybe I print the at the same time, you also realize that I may not use the word print a lot. I'll just do this so that when it prints it'll just print the last line. So most cells will just print in the last line without you using printer. So for example, when I use the split, right, you see from here, it got transformed from a string into array, but then it picks up the individual sentences on its own. It's splitting on the backslash n, which is the new line. I think ASCII. I think the correct term should be the new line ASCII character, lah, which is you can't see it, lah, but it exists, lah. Okay, so then for line in my corpus.lines, what you should intuitively know in Python is that you will get each value, lah. Okay, so for example, if I press uh, if I just do print line and then I run it, you'll see it just prints each individual line, lah. Okay, but what if I do I print line then I break. Okay. Okay, that's not good because the first line is a space. But I think never mind, you understand what I mean. I just print the individual line. So this to let you know how you debug Python code regularly. You will just print and then you see how the function works. So hopefully that will help you. Okay. So for line in my corpus line, if I print each line, so this is printing each line. But what if I want to split each line? So if I want to split each line, this code itself will break up the sentences into their individual words lah. And scroll. Oh, sorry. So I scroll. Okay, so maybe we don't really have time for any questions lah. But it's also for you to think about how to use these statements lah. So try to apply dot split to the string my string equals to today I'm learning about engrams into an array of words from the string lah. Okay, so your expected output should be today I am learning about engrams lah. Okay. So I'll give you 1 minute to try this. So let me zoom out a bit. Let me zoom out a bit so you can see the syntax of how line split is being used. Okay, so for some of you that just came in, if you need the material, I'm pasting back in the chat. Okay, so I give you 1 minute to try it. So how to use the dot split if you forgot how to use the dot split. Okay. Okay, because I think we don't have a lot of time for today. So I'm just gonna go through the answers lah. Okay, so in a sense, you see, you define my string as equals to the quotes. Okay, so I'm explaining in excruciating detail because in case you need some refresher lah. So how do you use the split? You use the split this way lah. Okay, so my string dot split. And then you realize if I don't put anything inside here, I'm splitting based on the spaces lah. Okay, so for example, if I do this, it will not split based on the space lah. But actually the default parameter is like this lah. It's a space here. Or if you want to split, you can split by A as well. Oh, sorry. You can split by A and then you see that today is split by A, and then it's splitting by an A in between and it's not getting the A as well lah. So it's avoiding the A lah. Okay. So I mean I won't break down the split into a smaller line of code lah. That will be or I won't decompose it into a simpler line of code because it is still doable, but it will bore all of us lah. Okay, so this is how you do the split lah. Okay, so a split you want to split words lah. You'll be using a lot of that split lah. Okay, so now let's look at what if I want to split the words individually lah. So the reason why I'm explaining this is because you see the output just now. You see the output of splitting the words here. Yeah, getting all the words as a split form. That is what you will also do when you are doing this sentence dot split. So later you can. So I'm just breaking it down in detail. Okay. So one way to do it is you define a word array, and then for uh each word in your corpus lines, you will just define a complete word which is there's no words inside, and then you will add in each character of each word. Okay, so let me print it like that. Okay, so you're adding each character of each word to this complete word, and then after you're done, you will add it add this complete work back into the array lah. This is what you'll do if you don't have a library lah. Okay. But I think this one you can see it on your own when I send you this notebook. Okay. But now let's try a small exercise and let's try to see how you can remember how to do this comprehension. Okay, so imagine if I want, because that is the concept that I should touch on again. So temp list equals to 1, 2, 3, 4, 5. And then if I want to convert this temp list into a squared list, such that it's 1, 2, 3, 4, 5 by squared. So it's 4, 5, 1, 4, 9, 16, 25. Because 1 times 1 is 4, 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. And then 5 times 5 is 25. Okay, so because of that, what I want to do is that for I in temp list, I'll add to the square list I times I lah. So for I in temp list, I will be 1, I will be 2, I will be 3. Then I times I, so 1 times 1, 1 times 2 times 2. It will square it and then you get that list lah. Okay, so because of this, there is also another way for you to do list com is I mean to get the same result using list comprehension. This is what you will do lah. So you look at this squared list versus these three lines of squared list lah. So you can see that this squared list you have to make a new variable or make a new list and then you append each element and then you square it when you're using the for loop lah. But this logic is the same as this single line is the same as these three lines lah. And the importance of doing this comprehension I think the main argument is that this comprehension is actually complex. It's more computationally efficient, meaning that it will be faster when running code lah. So, but at the same time, the other pro is also because of the way it looks and how confusing it looks. If you know how to do this comprehension, actually you are classified as quite a good Python programmer as well lah. Okay. Okay, so it's about 7:42. So maybe I will leave this question here. So I'll leave this question here as a refresher for this comprehension. And then at we will start again at 8 o'clock. Okay, we'll start again at 8 o'clock. So you can try out this question and take a break. Okay, so you can try out this question if you want to try out. If not, you can just take a break first and we'll come back at 8 o'clock. Test. Okay. So it's about 8 o'clock. Muted already. So I think Gina sent the all the correct answers. That's very good. So as long as you uh get used to this list comprehension, I think for today's class should have no issue lah. Should be quite straightforward. Okay, so if you have tried it, good. Besides that, I can repeat one more time, which is I will send you I'll send you this notebook by the end of today lah. Then you can see it as well lah. So this is just additional steps for me to break down the details and give you some questions to think as well lah, to have a better understanding for today. Okay, so let's go. Okay, so in the code that you have, then now I know there's another line below which has the counter, but we don't go there first. We look at what you are familiar with already, which is how to read the file, and then but instead of using the for loop, you use a list comprehension. So corpus equals to list comprehension sentence dot split for sentence in corpus. So another way to write it is for sentence in corpus sentence, but sentence dot split lah. So what happens is that you just imagine that the for loop is for each sentence. Well, sounds like JavaScript. For each sentence, split it into its individual words lah. Or split it every time you see a space lah. So then you see now your corpus is all this all are singular words inside an array of array lah. Okay, so that should be quite intuitive with all of you lah. I know list comprehension, you have learned it before, but if it's still hard to wrap your mind around, you will have to get used to it lah. And it also shows that if you're able to do list comprehension, you have advanced as a better Python programmer lah. Okay. So next, the other thing that we will go through is this idea of using a different library lah. So if you're familiar with the counter from collections library, you want to import a counter lah. So that's sad to say, all these libraries, right? You have to memorize how the syntax is like, meaning that how it's used, because the developer of these collections decide to use as a specific way lah. Okay. So besides, after that, so when you convert it all to single words already, you want to count what you see here is that what's happening is that you want to count the words inside all these things lah. So for example, the corpus that you had, the original corpus, you want to count each individual word and the output will be as such. There's also a most common. So for example, if I comment out the most commons, it's roughly the same. It's just a slightly different format. One is with the array format. The other one is without the array format lah. So I show you again. So one is still in its class form. One is that is not in its class form lah. Okay. So let me break down this part of the code for you. So from collections import counter, when you print counter, then you're printing a class from the library collections, and it's called the counter class lah. So as I say, a class if you're already taking an OOP, right, then this counter is some uh code that has been written to help you do some form of counting lah. Okay. So imagine if for example I want to get words. Okay, let me run it. Okay, run this first. Okay, oh sorry, it's a lag. Okay. Okay, so in case you don't know what I'm doing when I'm running the code, right? Usually I don't press the plus button. I click Shift Enter or Control Enter. Most IDEs or most ways you run code when you run Python usually is Shift Enter or Control Enter lah. So I'm just typing with my keyboard, but you can't see lah. Okay, so one way to actually append all the words. So for example here, let me uncomment this. If you just want to add all into the words, what you can do is that sorry, what I'm trying to say is that if I'm trying to break down just now that statement over here, the word for sentence in corpus for word in sentence, the for word in sentence in corpus for word in sentence. Okay, this is quite unreadable lah. Usually we hope people don't write like this as well lah. So for word for sentence in corpus for word in sentence is broken down into exactly this lah. So what it looks like is for sentence in corpus, which is above here, for sentence in corpus, for word in sentence is here. So it's a nestled for loop, like a nestled list comprehension. But you want to access the word when you do the first for loop and second for loop, you want to access the word lah, from here lah. Okay, so this is what it looks like. Yeah, it's hard to understand lah. I mean, it's hard to picture it lah, but just imagine that it's running sequentially lah. Okay, so for sentence in corpus, for word in sentence, words dot append. So it's an empty array, right? You're appending each word to it lah. So you're adding each word to the words lah, and then you can get the individual words lah. So I'm just breaking down this part. So you may not fully understand what this is, and you may not even write this in its form, which I won't as well. You'll probably write it as a for loop and then the list comprehension because it's easy to understand. Okay, so this is what it is. I'll send you and you can see it. Okay, so let's see how the counter works on its own. Okay, so the counter is just now that class to help you count things. Okay, so for example, if I just use counter and I do on words, then you can see it counts the words lah. So that's just its basic function. So just now the words you can see are all individual elements and then you are trying to count it lah. Okay, but then because this is quite hard to read, then normally I use indexing lah. So I'll do an indexing of the one to four element 0, 1, 2, 3, 4, excluding 5 for yeah, excluding 5. So this is also one way if you forget your indexing lah. So counter, you want to count the number of words. So electric occurs once, or maybe a easier way of me showing you lah is that let me print words 05. So you see my print word 05 is the first 5 words, which is electric cars are the future lah. And then the counter will sort of uh count all this lah. So electric occurs once, cars occurs once, are occurs once, the occurs once, and future occurs once. Okay, so that's what the counter will do. Oh yeah. Okay. So next we will go through the high level understanding of or the part that you instead of splitting according to words, sometimes you may want to split into characters lah. So characters is individual letters inside the word. So for example, if the string is slash kaggle slash all this, right? This could be considered as a word, but then each character would be slash is a character, K is a character, A is a character lah. Okay, so you're familiar with reading the data from Kaggle. You're familiar with reading the data from Kaggle now, right? So when you read the data from Kaggle, what happens is that you just save it as the corpus lah. And then there's a bit of a difference now. So I'm running the second part. You have your own notebook, right? And then when you see it, I'm running the second part where it says character tokenization. So it looks about the same, right, as the word tokenization, right? The first part that I went through, right? It looks about the same, right? You open the file, you do some form of list comprehension, you use the collections, library, import counter, use the counter, and then you count with this very verbose and difficult to read syntax, and then you print out the order. But how come the count is in character instead? Okay. How come the character count is in the character instead? So if you scroll up and down, you compare. I'll just summarize it for you. Is that the difference is here now? The difference is in this part. The previous ones was sentence dot split. So you're splitting by the spaces lah. So each sentence you will split by the words. Oh, sorry, split by the space. Sorry, and then the list dot sentence you are converting each sentence into its individual characters, which I'll show you later again. And that's why it's saying that there are 46 spaces that exist. So okay, so how to interpret this is there are 46 spaces in the data. There are 37 E's in the data. There are 27 A's in the data. There is one apostrophe. There is one capital letter M lah. Okay, so this is how you read it. You can break it down into character instead of words lah. So just now the example is all these words. These are the count of words. R is the count of words. R3 and then space 46 E 37. Okay, so let me show you what the difference is just now lah. Okay, so the difference is that if I run this, and if I run only the top, uh, if I run the same code as the first part, which is the sentence dot split, right? Then if I'm running it, if I don't index it, you get each array, which is each sentence lah, is broken up into its individual word component lah. Okay. Uh, but what if I use the list? Okay, so I use the list, it will break up into each individual character on its own. Okay, so for the sake of not seeming very verbose, if I put copper zero, then it's the whole sentence, it's the future of transportation. Okay, so that is very verbose and long, but let me show you what the list does. Okay. Okay, so for example, you see I open the data set again, the corpus data set, the few sentences, for sentence in corpus print sentence lah. So, and then I put a break there because I just wanted to show you each sentence being printed lah. Okay, but what if I did a list instead? So if I did list, oh sorry, to print. Uh, if I print the list, you can see it just each sentence becomes its individual characters because you're converting the the whole sentence into its individual constituents lah. Okay, so that is what is happening. The list on its own is just the a library that exists in Python that splits it into its it just breaks everything up into a list lah. So if you do okay lah, I won't label on that. You should be quite familiar lah with that. Okay. So now then we are finally going to the part of actually doing how to uh, um, uh, do your most basic language model, which is using that n-gram probability that we talked about. Okay, so there'll be a lot of helper functions. You will see a read file in your code at the bottom. You'll see create bigrams, and then you will see save bigram, and then you will see generate sentence. Okay, let me go through them individually lah. Okay. So for helper functions, what are they is that you are defining functions lah, to help you write your code, or in a sense you want to use functions so that you don't repeat code in the future lah. So in Python, if you recall correctly, uh, okay, wait, sorry. Besides the import statements, if you forgot about how to use libraries, the way people have wrote code so that you can use their code to do simple things that's being done, you can see that there's some libraries here and later I will explain when it's being used lah. But just remember there'll be a random, you know your collections and then you know the JSON lah. Okay, I mean there's JSON counter, default dictionary from collections, all these things lah. So when you want to do a function, right, you do define and then you call whatever you want. In this case, you call it read file, and then for function you can pass in a variable lah. You can pass in an argument, or you can pass in a parameter if you want to pass in lah. And then just remember that there's this colon down here, and you need to use a return lah. So when you call the function, for example, I call read file. After I defined it, it is syntactically correct. It makes sense. I'll be able to call it here. And then I call it with the variable of the file that I want it to read, which then this becomes the path. So this one goes in. Or I think the other way I can write it. This should be fine as well. Okay, yeah. So actually, if I don't write path, I just put this here, right? If I just put the text inside, it works the same. So this will fly into here every time I run this read file. The path will always fly into here, and then with open this path with the read only sign. Okay, you have to sort of memorize it lah as file, then read the file lah. So it's a bit different, but just treat it as it's like the read lines and it's reading lah. Okay, so. So just look at the output that is happening when I read inside the file. It's breaking down into its individual words. So how is that being done? So first, with when you open the file, I read it and then I split each line, each file by new line. So I split it into sentence already, and then list comprehension, which is I'm splitting by the individual spaces lah. Okay, so individual spaces look like this lah. If you recognize for loops well, so this syntax of list comprehension is equals to this down here lah. For x in lines, lines dot append x dot split. I mean, you must define a new array as lines lah. So lines will be a blank array. For each word in each line, append, and then as you split it, you get the individual words, and then you just append it lah. And that's why it becomes the individual words lah. Okay, so I will not explain this comprehension again, but just take note that each line you want to split it and you want to put it as a new variable inside the new file lah, and that's how you get this lah. Okay, so these are just the same thing to just a refresher lah from what I just said. So repetition lah. Okay, then the next one is create bigrams. So if you forgot already, a bigram is like uh you want to take its current word and the next word, or you want to take its current word and the previous word, and you want to save it as this two-word combination, meaning that I like food. So as about the bigram, you will convert the I like food. I mean, you process it first according to how we have been processing. You break the I like food into an array of I as the first element, comma, second element is like, and then the third element is food, right? So you split into I like food, and then when you create the bigrams, your bigram should be there will be one element of the array that says I like, and then the second element of the array will be like food. Okay, so that would be the bigrams in this case lah. Okay, so this let me try to zoom out a bit, zoom out and focus a bit. Okay. So if I zoom out and then you see the create bigram, when I run so I'm going to run create bigram, okay? So just remember it's the function here first lah. Okay, there's a lot of code. Let me try to hope let you hopefully see a sample of what I'm trying to do lah. Okay, just to let me clean it up a bit so it's easy to see. Okay. So I'm going to create bigrams, right? Okay, so when I run create bigrams, the output that I'm expecting is that I am counting the bigrams lah. So how you read this is that whenever the word technology occurs, the next word, if the inside the data, the next word that comes out would be whale. So this is the temp data that I'm showing you lah. Okay, this is the temp data that I'm showing. Yeah. In this case, this temp data, when I run it, let me run it. You can see that technology occurs once and then followed by will. That's why there's a record of technology and will, but it records twice because there's two technology will. So technology will and technology will, it records two times lah. So conversely, for example, if I do this, I comment it this way, then you see I remove the bottom, right? So technology will occurs once only. Okay. So that's just a sample for you to see lah. Okay. Yeah. So I think because of that, maybe I just get rid of this first. Okay. So how what is happening is that when you create the bigrams, you are giving lines of code lah. So the lines I'll be giving is the temp data, which is technology will solve all of humanity's problems. So imagine this temp data. So if for sake of explanation, lines equals to temp data. So this temp data goes inside here. So the bigram, you define a dictionary. Just treat it as a normal dictionary with a counter lah. This one, there's no intuitive way of getting it. You have to sort of memorize how it works lah. Okay. So you can sort of see that you are defining a bigram, some way to do the counting lah. So your default dictionary counting is here lah. Okay, your default dictionary counting is here. So for line in lines, for line in lines, meaning that each individual element, in this case we only got one element, but we can have two elements lah. Okay, so technology. I just didn't want to make it too long, so it's hard for you to see. Okay, so I just put technology will, and then just to demonstrate again, since I added new data, I run it. You see technology will becomes two counts, but then will solve, there's no will solve here. There's only a will solve here. That's why there's only a single counter. Okay, so because of that, let me show you typically how you will want to understand code because for better or for worse, if you're going to be a Python programmer or any form of programmer, sometimes you need to take over people's code lah. And then when you take over people's code, sometimes they don't document it well. They document something that's very obscure and hard to understand. So because of that, you will need to figure out how to professionally you can do breakpoints and then you can pause the code when you are running it and debugging. But the easiest way is to do print statements lah. Okay, so you see for line in line, right? Let me print line. Let me print line and let me do a break as well. Okay. Okay. So you can see here. Uh so when I printed line, then the line will show you each line. First line will be technology will solve all its humanities problems down here. And then I did length in line. So length in line because you'll use it later. So the length in line is 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5. So the number of elements is 7 essentially lah. Okay. For a better way of explaining it, let me remove the break instead. So it throw you error? It won't. Yeah. So you can see that for line in lines, the for loop will print technology will solve all its problems because this is my first line. And then the length of the number of elements is seven. One, two, three, four, five, six, seven. And then here you see it's second line would be technology will, and the line is two. Okay, so you all should be familiar with this. Okay, so let me run it again. Okay, so now when you're so for line in lines, right, you're printing each sentence, right? So each sentence will be this will be one sentence, and this will be the second sentence, lah. So for I, which is an index or a number, right, which range length of line minus one, right? So length of line minus one is just counting the number of lines, and then just minus one at the end, lah. I think if you remove it, it will not cause you an error, lah. But some people like to make sure that you don't account for the last range of the word because there's no bigram that exists in the last word. There's nothing else to add it to a bigram. Okay, but what happens is that let me give you a sample. Okay, so right now this is going to loop through each line and it's going to loop through each word. Okay, so you see that you see for this for loop, right, each line will print for I element, will print the word technologies. So I will be the index. So this index zero, right? And then it prints technology. Then index one is will, and then index two is solve, and then all is here, so on and so forth. Okay. So I think that one you all should be familiar. Okay, run it again. See if there are any errors. Okay. So after that, it will convert the key to the word. So what you're doing is that you are updating the dictionary's key. So what a dictionary key is here, right? So key value, right? Key value key value, key value. Okay, right? So you're gonna put key as actually it's not necessary to put one more line that says key and then you can just put line I here. Okay. But essentially what it's saying is that line I, just not printed line I is technology, right? So technology I'm putting in the dictionary technology. So the first time I run, technology will be here, but I'm going to dot update. You don't have to do dot update lah. There's another way of writing it, but update is one of the ways to add in the value lah. So dot update value, as line I plus one. Okay, so why I plus one? I plus one means the future word, right? So for example here, technology is the key. Define here, technology is the key. Uh, I want to update it. I want to update the value. So the value is line I plus one. So line I plus one is what? Technology is I plus one is will. So if I is solve, then I plus one is all lah. That's why solve and all. Okay. So what you can see the logic lah is counting and counting and counting lah. Okay, but let me show you the logic. For example, if I print the bigram before it is being added into the dictionary lah, and I print after the is added into dictionary lah. So let me run it. So you can see bigram before update technology. There's nothing. They didn't count anything. Then after you see bigram after update technology, and then technology counter I plus one. Bigram before update for the word will. Technology counter still will, but then technology counting will plus solve. And then you can see it grows slowly lah. So you can see the technology will and then will solve and then solve all lah. Okay, so I think you have the intuition already. You have the intuition already. So let me comment this out. Then I'll send you. Okay. Okay. And then the other one is that, so for example here, uh, this code is just simply saying that, defining the function, the same thing, and what's the parameter. So I'm just going to give you a sample here. Okay, so the sample here is that save bigram, I created my bigrams using the function above that we defined. I created the bigrams, but then I'm going to use this bigram data lah. So temp data, I'm using this and then I am putting it to here. So temp data is here, and then this create bigrams will create the bigrams lah. So the created bigrams will come in here, and then what's happening is that very similar syntax you need to memorize lah. Most of it is not very straightforward lah. So when with opening bigram JSON means you want to create a JSON file. W stands for write. So just now above, you have it was R, so R is read. This is write lah. So you want to open a new file that is bigram.json. You're creating lah essentially, and you want to write it inside as a file. Then JSON dump is that you want to make you want to convert it as a JSON, and you are doing something like a list comprehension, but this is called dictionary comprehension because it's using the curly brackets lah. Curly brackets. They are the curly brackets, and these curly brackets are the list comprehension, and then you are putting the file inside. Okay, you're using the file. In this case, you are using the file here for dictionary K V for V and V bigram items using the bigram. The bigram is here. You're doing a for loop and you're using dot items, which is the dictionary function. Dot items, you're getting the key and value pair. So key value, and then you are putting inside the dictionary lah. So K would be the key. So K is the key. This K is the key here. Then you want to dictionary the value lah. Okay, so it's quite confusing. Don't need to memorize it, don't need to remember so much. Just take note of this lah. Okay. So what happens is that when you run it, I don't want to run it again, but when you run it, right, it should open up, it should save for you. Don't have. Wait. Yeah, it should save for you. Oh, don't have. Okay, let me run it. Let me run it. Okay, so I ran it. Uh, it should appear somewhere. Hmm. I think it takes some time to load lah. Don't know where is it. Okay, it's loading. Okay, I think we may need to wait for a while. I'm not sure why it is not saving. Okay, I think it takes time to refresh. Oh, okay, see. So I refreshed it and then you can see it appears at bigram.json. So called it bigram.json. You can see when you open the panel at the bottom. I mean, you click this caret button, it opens and closes. Then you can see that the JSON is created. So what you can do is that you can click here, you click download, and then you open with whatever system you want, and then you'll be able to see the bigrams that are saved. So in this case, the bigrams that are saved for me is, oh, where did it go? The diagrams that are saved for me when I open it in Visual Studio Code is here lah. Technology will solve all the problems lah. And then there's a file path which I erased lah. Okay. Okay, so that is it for the bigram saving part. Okay, so now is the part that is quite lengthy. Oh, I realize it's hard to see. Okay, if I zoom out. Okay, I zoom out, it's also hard to see. Okay. Okay, let's see. Is there a better way for me to do this? Okay, so basically, okay, let me see. Can I split? Okay, I think I can't split from left to right lah. So you're gonna have to bear with me lah. So you're gonna have to refer to your own code as well lah, because you don't have this sample yet, right? Now, of course, I'm not giving you this first because you need to read through and to test it first yourself lah. Okay, so under the first generate sentence, you're giving it a bigram and then you're giving it the parameter start. Okay, so bigram and start. So what are these bigram and start? Okay, so let me just show you how I call generate sentences lah. Okay, so generate sentence, I create the bigram. So we created a bigram with our function that we define lah. Okay, so the temp data is this, right? So you look at the temp data. This is the temp data that we have. Technology will solve all of humanity's problems. I repeated it twice, and because I repeated it twice, then I actually don't need the second line. Actually don't need the second line. So for example, I run this, you remember that the create bigrams creates a bigram. So the first parameter is bigram lah. Bigram. So just in case it's hard for you to read, and then start is here lah, right? So start is will. So what does start will mean? So I run. It says the starting word is will. So will solve all humanity's problems. So I just gave it the word will, and I gave it the bigrams, right? And then this is the first language model that you have, the most basic form of a language model, which is then it'll print out will solve all humanity's problems. Okay. So for example, if I use all, it uses the bigram logic, and then it says it'll complete the sentence all of humanity's problems Okay, so same if I do technology. Then after that, it will print technology will solve all of humanity's problems. And it's purely done with the logic down here with the diagrams that is given. Okay, so let's explain the logic. Okay. Okay, so for example, generate sentence, we know that this is going to generate like the autocomplete sentence lah. So what is the it's going to use it's going to make a guess and it's going to decide given a single word that starts. So I'll start with will instead. Given a single word that starts at will, how should the other words follow? Okay, based on the data set, the create diagrams lah. Okay, so create diagrams is it will say technology and sometimes the word will comes after it two times. Okay, so that's that diagram, right? So from here, what you can see is that sentence equals to start. So uh so you should have the intuition that sentence will be the array that we're going to define, and the first element is going to be start. In this case, it will be will. So will be the first element inside start, and then key equals to start also lah. So key equals to start because we will use it later in the diagrams lah. Okay, so while length of sentence is lesser than 20, so right now the first pass is that the first element inside the sentence is only will, right? So first element sentence only will. So will is still less than 20. This is not needed, but this just to prevent it from running forever lah, and have a way to stop. So if key in bigram, so in key, what is key? Key if will, the word will, right? The first element, if will is inside the bigram, then it will run the for loop. Okay, so let me print for you bigram again, just as a refresher. So bigram, oh, bigram print too many times. Okay, wait, oh no. Let's do this then. Like easier to see. Eh, yeah. Let me print like that first. Okay, so let me print like this first. I'm going to print the diagram that's been passed inside, right? So the diagram that's been passed inside is technology will, solve, all, etc., etc. And then what I'm going to print is that diagram dot key. And then when I print diagram dot key is will first, right? So when I put in will, then it will give me solve lah. That's why it's solve down here. So diagram key. And then bigram list keys would just be getting all the keys that exist inside here lah. So all the keys is solved. And then bigram dot values, all the values that's inside this data set, it's only one lah. Okay, so that is it. This part may be a bit confusing lah. Okay, so that's just to refresh bigrams and dictionaries for you lah. Okay. Okay, so if when I stop the break statement, it will continue running. Same, we'll solve all humanity's problems. Now we are not doing any formula. We're going to say that what is the next word in the sentence that should be based on the diagrams. Okay, so that is the semblance of what you should be getting or understanding lah. So in this case, the next word equals to random choices. List bigram keys dot keys. List bigram keys dot values, which is what I was saying, right? So convert to a list all the bigrams that will match with uh the whale lah. So whatever with whale, I want to know the keys that exist with whale, and then whatever the values, what is the number of times or the word count that occurs lah. Okay, just ignore the zero as well lah. Okay, but essentially what is saying is that uh essentially what this logic is saying is that you are using the random library. Okay, let me give you this example here. I'm not gonna print it, but imagine all these values here. Okay, now I'll print it. Okay, easier to see and to understand. So you see, right, I'm gonna print the demo down here. So demo of random choices is 2. Then let me run again. Demo of random choices is 2, is 2, is 2, is 2. Okay, why is it always 2? Yeah, now it's 1, 0, 2, 1, 2, 2, 0, 1. Okay, so just to demonstrate what that means is that you can see what I so random choices is just is going to give you it's going to choose a random number for you lah. Just treat it like that lah. So 0, 1, and 2 are the choices. 25, 25, and 50 add up to 100, right? They're the probabilities lah. So what that means is that whenever I run this random dot choices, there's a 25% chance it will be 0. There's a 25% chance it will be 1. There's a 50% chance it's 2 lah. And that's why when I ran it most of the time it's 2. You can see at the bottom the demo of random number is 2, is 2, is 2, is 2, is 0, is 1, it's 1, is 1, is 2 lah. So what is happening? Let me do this is that so what is happening is that for the next word I want to have a random choice. This just that there's no statistics involved now, like. There's no probability involved now. I'm just going to tell it, right, the random choice I want, and what word is it. I want to know what's the word it is, but I also want the probability of the word occurring. The probability of the word occurring is actually the how frequent the word actually runs, right? So in this case, if the word runs more frequently, right, then you can see the probability of it actually working is higher lah. Okay, the probability of the word the probability of the word existing is higher lah. So right now what is happening is that it is still doing a random choice lah. So you're doing a random chance of predicting the next word, but then it's relying on the bigram data set lah. Okay, it's relying on the bigram data set, and then for the next word that it has been chosen, then you will just append the next word into the sentence lah. So the sentence started with will, and then because will solve is the only data that exists in this random choice, right? So it will choose the solve and then you append solve inside. And then the key is the next word. So key, next word becomes solve. Solve will become key, and then it will run the while loop again. So you do the same thing. The solve will be the key. It'll do a random choice between all the words that exist after key, and then what is the probability of it. Okay. And then after that, to return the generate sentence function, you join the whole sentence back together with spaces lah. So you are just making it into a sentence back lah. And that is why when you do that, then it becomes a full sentence like a string. It becomes a full sentence like a string. Okay. So that is a giant mouthful. But this is needed. We are quite close to the end already because we're going to do almost the same thing but slightly different in the next run. Okay. So when we go back, oh, okay, wait. Okay, so this is just the whole demonstration of when I do a main function, I use all the files that we did just now. I use the read file. So I read this file, we define this, right? So I did the read file. And then we also talk about the create diagrams because we made the create diagrams. And then we also did the save diagrams, which is not necessary. I don't really want to save more JSONs into my file. And then we print the generate sentence lah. Okay. So for example, vegans are are the future of humanity's problems. What if I say all of humanity's problems? What if I type the word people? There's no next word prediction. It stops there. Oh yeah, sorry, because I didn't explain is that the if statement is that if there's the key exists in the bigram, which means that if the word exists in the bigram, so any of these words exist in the bigram, then after that it will do the if statement. If not, it will break, meaning that it will stop working at all. So in this case, the for example, just now I typed people, right? People think exist. So people think, but if I do people then because of the capitalized keyword, right? It does not exist. There's no in the data set, there is no capital letter people followed by another word. So you'll just end. But so for example, if I do will, then okay, so this is exactly the same as Royden's question. So Royden's asking what if there are two of the same words in the sentence. So let me go back to the corpus again. So the corpus just I forgot to explain that corpus just means the data set of words. So read the corpus again. So the corpus was this lah, right? Electric cars are the future of transportation. Technology will solve all its humanity's problems. I've been using this word a lot, right? So there's also then the renewable energy will completely replace fuel fossils. Okay, so you can see will exist here and will exist here as well lah. So two of these words exist as well. Yeah. So I realized Roy didn't send by direct message, but just to let you know, he's asking what if I want to choose the word will? So how then will the model predict? Okay. So will it do will completely replace fossil fuels or will it be will solve all humanity's problems? Let's scroll back down to the code. So too much, I think. Yeah, too much. No, 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 no. Where am I? Okay, so you see I put will here, right? So will and then it will complete the rest of the sentence. Let me run it a few times. So will complete fossil fuels. Stop running. Yeah, will. Sometimes, what happened? Uh, That is rather awkward. Oh, I think something broke in the code. Hmm. Something broke in the something changed in Kaggle. Doesn't seem to be working, right? Okay, let's run all. Oh, okay. So yeah, after I ran all lines, background lines, main, generate sentence, background will. Okay, just let me run all lah. Okay, I'll run all a few times just to prevent the error lah. So for example, so based on what Royden is saying, if I have the word will, what will happen? So I run it, run all. There you see, will completely replace fossil fuels. It's generating a sentence here. I run again. See, we'll solve all transportation. So right now the logic is random lah, right? We're doing a random choice. There's no math involved in choosing what is the option because the will solve all humanity's problems occurred once. Okay, let's go up again to explain one more time. The because it's completely at random now, so meaning that the will completely replace fossil fuels exist and the will solve all humanity's problems are each occurring once lah. So will completely uh happens once. Will solve also happens once. So right now there's no algorithm, there's no thinking, there's no probability. So there's an equal chance of it showing up at the same time. Lah. Okay. And that's why when I demonstrated just now live, then it is the same. Lah. Do we include probabilities? So Hajit's question is, do we include probabilities for words that exist more than once? Like will 50, do we include probabilities for words? So inside the bigram, right, the more frequently the word occurs, naturally the count will determine that it occurs more than once already. You understand what I mean? The probability of uh um because inside this random choice, right, you are you have a list of items of how many times that word occurs at the same time lah. So for example, if the word occurs 100 times, like the word will occurs 100 times, then this value of probability will be 100 lah. Okay, it doesn't need to add up to 100 per se lah, but it will say it will sum and then you do all the things for you lah. But the higher the count, the higher chance of it happening lah. Okay, the higher the chance of it happening lah. Okay, so I know that this one takes a bit of time to digest, but I think we are running out a bit of time. So I will send you this and you can play or you can play around it with it yourself lah. And but I'll send you this notebook later lah. Okay. Uh yeah. Okay. Yeah. So let me go through the last part for today lah. Okay, last part, which is about the same thing lah for most of it. Okay. So same here. We will be going through the same thing, but we'll do it character prediction instead lah. So character prediction is that what is the difference? Same as what we have been going through. The difference is that uh there's a list now instead of the dot split. So if you remember, so if I read the file, then now we are just splitting according to the individual characters now. Okay, so you should be relatively familiar a bit lah. I've said this a bit. So the list helps you to split the individual words or individual sentence into its characters now. But it's a bit messy, so I comment it. Okay, so we are doing a different read path. For the create bigram, if we are just doing characters on its own, right? Imagine that I just give the temp data, which is all the characters, and then I print the create bigram. It's doing the counting of the given the character, what is the next, how many times the next word is occurring lah. Okay, so this is to answer Harjit's question as well. So you imagine if there are occurrences of a lot of characters or words that exist after the current word. So meaning E occurs when E happens, how many times does the word N occur after that in this data set? Twice. So N here and N here. And N here and here. Okay, yeah. Uh, E, how many times R occurs after that? So ER one time. So that's why one. And then EL, where is EL? Then there's one also. Okay, so imagine that what happens in the probabilities is that N will be a chance of it for the randomness, like N will be a chance of it occurring N will be N can possibly come after E, R can possibly come after E also, L can come after E, but then two, so it'll be 2, 1, 1, which shows that the more the word count, the higher probability it will show up lah. Okay. So the logic is the same. I won't explain the create by game logic again, but just let you know the logic is the same lah. Now you're just counting the individual elements lah. Okay, so I'll leave that additional homework if you need, because our lab is only for 7 to 9. Okay, but let me go through the last one. The last one. Okay, the last part. So this is the last part. Uh, so same generate sentence is the same concept. Let me get rid of this space. Okay, let me get rid of this space. So inside the generate sentence, diagram start and temperature. So this time there's a difference. There's a temperature, but we are not using the random choices anymore. So you don't see any random choices. So I may just delete the random choice. So there's no more random choice. The same code, but no more random choice. But now we replace it with a formula instead of a random choice lah. Okay, so let me just run this code as it is. Now it's quite gibberish lah. It's just trying to predict what is the next character lah. So generate sentence, you give the bigram, you give what is the starting character, and then you give a temperature value lah. Okay, so you give a temperature value. Okay, so I think default is 0.1. Give a temperature value, and then it's predicting gibberish now lah. So it's predicting the next character based on the next character based on the next character lah. Quite gibberish lah. Okay, so same as the logic. The first word is the start. So the start is T. So T is at here. So T as the key. And if the length of the characters is lesser than 20, you will run this while loop. So if key in bigram, just a short refresher. If key in bigram, then you will track. Wow, so long. Uh, if key in bigram, then you'll print out. Nah, don't print out the whole bigram. I think the bigram, you know what it looks like. You print out the keys, which is all the existing keys all the existing keys. Sorry, I print out something wrong. Print key, yeah, all the existing keys lah. Which is here, all the existing keys, and then it's printing out all all the values as well lah. So values is the word counts as well lah. So just printing out the word count. Yeah, just printing out the word count. Okay, so I comment this out. The values are here. So okay, yeah. So what you can see is that the values, right, is the word count. For example, the 513. Oh, this is a bit it's a bit strange, but the what you can see is that if T is occurring, then after T there's the H, I, 3, R, so on and so forth lah. But what is happening is that for each of it occurring, there is also the count that it occurs as well. So inside the count. Okay, but instead of using the randomness, we're going to use the temperature formula lah. So in case you can't remember what the temperature formula is, inside one of the slides, as well as can look at your study guide, what you can see is that there's a formula for this lah. It's called the temperature formula lah. So EPT and then summation of all, and then you check the temperature value, which is T lah. So just the long and short way of it is that the temperature value is here, and then you're just deciding with this formula of the next word, you are trying to predict using this formula here lah. So for in using the numpy array, the exponential x divided by t, x divided by t, yeah, x divided by t, probability divided by t lah. So in this case, this x is probability. So for the probabilities in the probability, you just divide by t. So instead of using random choice, you're using temperature formula to decide what the next word is lah. Okay, so and for the temperature formula, what to take note is that the value of the temperature, the T, will determine what is the probability of the words occurring lah. So this graph then says that the higher the temperature, so the higher the temperature will be this will be low temperature, the 0.1, temperature 0.5, temperature 1, and temperature 2. You see, as the temperature value goes higher, the probability of it outputting more words, a very amount of words increases lah. So that's what the temperature is doing. It's helping you decide what words to do lah. Okay, so with that, that is the general concept of this topic lah. Yeah, so this is all the lab for today. Uh, if you have any questions, you can stay. If not, I will share this notebook with you lah. Okay, so let me share this notebook with you. Okay, so I'll put one here and then I'll probably put one in the announcements as well lah. Okay, so I'll just put the notebook here. Uh, yeah, and if you can't see and you're watching the recording and you have no way of finding it, this is the code as well lah. Okay, so if not, if you have any questions, you can stay. Uh, if not, I will see you next Friday for the next topic, which is more interesting lah. Diagrams is very tedious, very mathematical, but the embeddings is something very interesting because you will see words in two-dimensional, three-dimensional spaces and numbers lah. Okay, so uh thanks for participating for today and for the questions. It helps me to make class more interesting. So thanks, and I'll see you next week. Thanks, and I'll see you next week for class. Thank you all. Have a good night. Have a good weekend as well. Okay. You all, any of you have questions? Okay. If not, I'll see you all next week. Thanks for coming for class.